So welcome to End-to-End Machine Learning for Enterprise in a Secure Way. I'm Junpei Hirono, Program Manager, Azure Machine Learning Platform Team. And we also have co-presenter, Vijeta, another Program Manager, Azure Machine Learning Platform Team. So I have been working for machine learning and deep learning industry more than 4 years. And I saw many enterprise customers started using or started building machine learning platform. But building a machine learning platform in a secure and compliant way is super challenging because basically a company needs to craft lots of open source technology and multiple computing resources. And balancing the productivity of data scientists is also another challenge. So having said that, in this session, we cover how to build secure and compliant machine learning platform using Azure Cloud and Azure Machine Learning Platform. So having said that, let's get started with the presentation. So at first, let me cover the Azure Machine Learning fundamentals and what kind of resources Azure Machine Learning use. And after that, I will cover the key security considerations such as identity, data, and network. And then Vijeta will do the deep dive on compute instance. And after that, we will do end-to-end secure and compliant machine learning platform demo. And lastly, we shared some insights on roadmap and Q&A. So let's get started. So basically, Azure Machine Learning is a PaaS service to build machine learning platform on top of Azure. So we have many dependent resources on Azure. So let me explain one by one. So first one is associated resources. So if you provision Azure Machine Learning Workspace, you will get these resources. And storage for storing your data, keyboard storing your secrets, content registry storing Docker image, App Insight to monitor Azure Machine Learning itself. So they are the pretty fundamental resources to run Azure Machine Learning. So after that, you need to train AI model on Azure Machine Learning Platform. So we have two types of resources. First one is compute instance for the cloud-based workstation for data scientists, so for model development. And after model development, data scientists will submit a training job to compute cluster, which is a scalable training environment. And after model training, you want to deploy model to cloud. So it is called inference in deep learning world, scoring in machine learning world. So we support AKS and ACI for that. And additionally, you might want to mount additional data store, such as storage or SQL Server. So these four are the required resources for Azure Machine Learning Platform. So if you think about secure and compliant Azure Machine Learning, we need to think about each resource's security and compliance as well. So having said that, let me moving on to the security considerations, identity, data, and network. And first one is identity. So identity has two sides, authentication and authorization. So for the authentication, we have good coverage of authentication mechanism. So for workspace creation, workspace access, we support multiple authentication, interactive authentication, Azure CLI authentication, service principal, managed service identity. And for the training, basically data scientist wants SSH access to compute cluster. So we support that with storing secrets in keyboard. And for the inference or scoring, AKS token and key-based authentication is supported, and ACI key-based authentication is supported. And lastly, compute instance supports Azure AD authentication. So that's the authentication. And next one is authorization, in other words, RBAC. So Azure Machine Learning provides granular RBAC for multiple roles, such as IT administrators, data scientists, and data engineer. So below is an example of administrator and data scientist. So let's say, administrator can do everything, but we do not want to let data scientists to create additional compute cluster, for example. So if you look at the screenshot on the left-hand side, you can see plus new button or delete button for administrator. But if you look at the screenshot on the right-hand side, it is a data scientist view. You cannot see the new or delete button. So it's a part of granular RBAC. And by creating custom role for administrator and data scientist, we can apply this kind of RBAC. And we will create built-in role for typical roles such as administrator, data scientist in the near future. So that's the identity. And for the data protection, Azure Machine Learning supports encryption in transit and at rest, and using both Microsoft Managed Key, which is default, and you can also configure customer managed key. And in the case of customer managed key, additional resource group is created for customers DB to store metadata of Azure Machine Learning. Okay. And last one is the network security. So in order to think about network security, we need to understand the network communication between resources. So we have 3 big resources. So Azure Machine Learning Workspace, it is managed by Microsoft. And you also have compute resources inside your VNet or inside your subscription. And you also have associated resources such as storage, keyword, container registry. It is also inside your subscription. And so as a result, we have 3 communication paths. So let me explain one by one. So first communication is here. So your compute resources need access to Azure Machine Learning Workspace. And it happens over public IP by default. But you can choose private link enabled workspace. So with that, communication will be over private IP. And in Ignite, we announced GA workspace private link. So it will be available in all public Azure Machine Learning regions, excluding China and Azure government in September. So yeah, please try that. And for this communication, so for your compute resources need access to storage associated resources. So, and now we support service endpoint, and we will support private endpoint soon. So if you want to limit storage access only from your VNet, service endpoint, please configure service endpoint. But service endpoint itself has public IP. And if you prefer private IP, then please configure private endpoint for that. And we also have remaining communication paths, but this goes through Microsoft backbone over private IP. Okay. And we also need to think about communication inside your VNet, so such as compute instance and compute cluster. And this network architecture, as this network architecture shows, behind VNet is supported. But even we put compute resources behind VNet, they have public IP. And so some customer wants that. So for the private IP, it will be explained by visitor, but it is on roadmap. And for the model inference resource, AKS Cluster, AKS behind VNet, and private AKS Cluster both are supported. Okay. So having said that, yeah, I covered key security configurations such as identity, data, and network. So then let's do the deep dive on compute instance by Vijeta. So Vijeta, can you please?
Sure. Thank you, Jampe. Hello, everyone. So we think of compute instance as a managed enterprise workstation for data scientists, which make it easy for them to get started with machine learning development while providing admin management and enterprise readiness capabilities. All the resources are created in Microsoft subscription, so that is why we think of it as a PaaS service. And it's really an interactive dev test environment. So data scientists can run notebooks through their popular tools they love, such as Jupyter Lab, Jupyter, Azure Machine Learning notebooks, what we have in the left pane, and they can run R scripts through RStudio. Today, compute instance is Ubuntu-based. It's Ubuntu 16, and we're looking to upgrade it to latest Ubuntu versions. It is fully customizable by data scientists. They have root access, and so they can install any pip packages, app packages, or any drivers they would need for their work. So they have full flexibility there. It is tightly integrated with Azure Machine Learning Workspace and provisioned as a child resource of Workspace. And the notebooks which are part of the Workspace are mounted on every compute instance. It is also a training compute target where users can submit local or remote training jobs, including GPU distributed training jobs, which we will demo later on. And We recently went GA just a couple of months ago, which means we continue to invest heavily now on reliability, availability, and performance. So in terms of enterprise readiness capabilities, we have virtual network support, which is really needed by every enterprise for network isolation, a very key requirement. You can now provision Kubernetes instances in private link workspace, as we'll show in the demo. And you can use ARM templates, REST API, or CLI support to help automate creation and management. We also support admin create on behalf of data scientists and assign to them for use. With this, there's a clear separation of concerns where data scientists don't need to have create compute permissions. And we support RBAC, and through RBAC, you can control create, start, stop, restart, deletion, and who can access the notebooks. We support encryption in transit using TLS 1.2, and there is configurable SSH access using public-private key mechanism. In terms of data scientist productivity capabilities, each compute instance is like a pre-configured machine learning environment with the most popular packages and machine learning packages, deep learning frameworks, CUDA drivers, and really anything which data scientist needs to get started. And we already have created the content environments and Jupyter kernels for data scientists to use. You can use any of the popular GPU VM families which Azure offers, and can collaborate on the notebook files in the same workspace. Like as I mentioned, each component in the workspace has mounted the notebook in the shared storage, workspace storage. There's VS Code integration either through the remote SSH extension, and we recently released AZML extension through which you can run Jupyter notebooks in VS Code using Kubernetes as the remote server. And this capability doesn't need any SSH enabling because we heard from a lot of enterprises they don't want to open up the SSH ports. And Kubernetes is a secure compute target because it can be deployed in VNet, and it has a job scheduler which is backed by job queue, and also has ability to run multiple jobs in parallel. And for distributed training, we support like popular frameworks like PyTorch with Horovod or TensorFlow. We also have single sign-on support when using Azure Machine Learning SDK and notebooks, removing the need for device code authentication. And for ensuring work continuity, we support uninterrupted notebook sessions by preventing session timeouts.
Okay, so yeah, let's get into demo. So at first, let me explain the demo environment. So I provision a private link enabled Azure Machine Learning workspace in here. So as a result, I create private endpoint within your VNet. And I also create private endpoint for associated resources such as storage. And we have a bunch of training and inference resources such as compute cluster, compute instance, and AKS. And in order to emulate your access from your on-premise environment, we create VPN gateway to our VNet, and we are accessing to this demo environment from our presentation PC. And of course, everything is encrypted, and RBAC access control is applied. Okay, so let's moving on to the demo environment. So this is the resource group which has private link enabled workspace. So this is the workspace. Oops. I'm refreshing. Yeah, sometimes happens. Okay, so yes, so this is the Azure Machine Learning workspace. So let me launch Azure Machine Learning portal. But please note that I have not established VPN connection, so I cannot access to the workspace. So let me close this tab for now, and after that, let me connect let me establish the VPN connection to the VNet, which has Azure Machine Learning workspace. So it is connecting and connected. So go back to the browser and let me launch the ML Studio again. So now I can access to the Azure Machine Learning workspace, and I can see the bunch of experiment data and compute clusters. And yeah, go back to the Azure portal, and let me check the configuration of Azure Machine Learning workspace and associated resources. So at first, as I said, I created the private endpoint for Azure Machine Learning workspace. So this is a private endpoint. So if I click here, So you can see the private IP addresses. So basically, I use this private IP address to access to the Azure Machine Learning workspace. And if I go back to the resource group, and let me check the configuration of associated resources, for example, storage. So if I click storage and go to the private endpoint section, as you can see, I created the 2 private endpoints. So one is for blob storage and one is file share. So with that, every access to storage is over private IP. And if I go to the firewall section, as you can see, I have not created a service endpoint in here. Okay. And go back again to machine learning portal and go to the compute section. As you can see, I created, or actually Vegeta created a compute instance. And we have a bunch of compute clusters, CPU cluster, GPU cluster, no public IP clusters. And we also have AKS cluster, right? So go back to my presentation. So as confirmed, everything set up private endpoint, and you can see the resources and connections through VPN gateway. So then moving on to the second phase of demo by Vegeta, deep dive on compute cluster and compute instance. So Vegeta, can you start your demo?
Sure, thanks, Junpei. So I'm also in the same VNet which Junpei has set up, and where the Workspace private link is deployed. And my laptop is connected to the same VNet through the VPN connection, point-to-site VPN connection. So that is why I'm able to access the Workspace, same as Junpei. And when you come to the compute pane on the left side, this is where you see all the various kind of computes. And compute instances and compute clusters are the managed computes. And here is where all the compute instances are listed, along with the URIs for each of the applications we talked about, Jupyter Lab, Jupyter RStudio. And you could also SSH into the compute instance. I also want to take a brief moment to just look at a compute cluster. So this is a compute cluster which is deployed in that in the private link workspace. And what is interesting about this cluster is it doesn't use any public IP for communication, which if you see here, the public IP address is the same as the private IP address. And this address is a very key enterprise ask of removing public endpoints and really eliminating a big attack vector. Now, going back to the compute instances, so either you can create through UI, where you can choose CPU or GPU types, and for each of the VM types, you can look at the spec, where you can see things like the cost associated with it, and it only shows you the VM types which you have quota for, so it takes all that into consideration. And you can enable SSH access through public-private key mechanism, and then of course here in the advanced is the VNet settings. So what I am going to do is through an ARM template, I will provision a compute instance on behalf of Junpei. So Junpei will be able to access it, but I cannot access it. And this is the ARM template. These properties are similar to what were in the UI. And what is different here is the assigned to user. This is Junpei's AAD, tenant ID, and object ID. So let me kick it off. So this is just a simple ARM template deployment. So while that is happening, I had already provisioned a couple of compute instances. So this is a compute instance I provisioned on behalf of Junpei. Only Junpei will be able to access it, and when I try to access it, I'm going to get an error. See, it says, okay, I cannot access it because this is created on behalf of. So here RBAC is at work, and because Junpei has the RBAC action to access that particular compute instance, but I don't have that. So I will instead use a compute instance, which I've created for myself. So I'll use this GPU box, which has 4 GPUs. And what I would like to show here is a GPU distributed PyTorch run using Horovod. You could run your normal notebooks as well, but I just want to show you a distributed training run here. So what is interesting here is I'm going to use the warm compute, the compute instance which already exists. So if you use clusters, you'll have to wait for it to get provisioned and then scale up. Here, you can just use it right away. So it will find the existing compute instance. And it found it. And so it doesn't need to create anything. And just you can start your run right away. So create a project directory. Training script. So this training script is going over the MNIST dataset, a very standard public dataset which is there. and I'll create a experiment and then a PyTorch estimator using PyTorch 1.4 and the GPUs. And then I will submit the job. And then I can monitor the run directly in my Jupyter lab session through the widget, or I can go to the EML experiments tab, and our run will start showing up here pretty soon. See, it's running now. So this is a job which I submitted. So this will take a bit of a time. So I already had submitted another job. So this is one of the jobs I had submitted earlier. Same run, distributed PyTorch run using Horovod. And you can see here, it is launching MPI job with 4 processes. So I'm utilizing all my 4 GPUs in this MPI job. And this is, for instance, one of the MPI processes launched on the GPU. So it says, yeah, this is an MPI job. This is the first one. And it is using PyTorch 1.4, and GPU is enabled for this job. And yeah, so yeah, I think that is it. So that run is still going on. And yeah, Jumpe, please go ahead. Yeah.
Okay, so thank you, Vijeta. So yeah, back to presentation. Yeah, Vijeta briefly explained the private IP-enabled compute cluster and submitting about the GPU job from his compute instance. So as he said, he created compute instance on behalf of Junpei. So yeah, let me check the access, and after that, let me quickly show the AKS cluster itself. Okay, so yeah, go back to Azure Machine Learning portal. So Ignite demo page CI1 is the compute instance created by Vijeta. So let's click Jupyter, as Vijeta said. Then I can access to Jupyter notebook. So yes, so I can access that. Yep, with that. And if I go and after that, let me quickly explain the deployment to AKS. So in this case, I use Jupyter Notebook to deploy AKS cluster, but of course, you can use CLI or UI, whatever. And in this case, scroll down, and in here, I create AKS cluster behind VNET. So I configure VNET information in here. And I also enabled load balancer. I also enabled the internal load balancer. So in order to deploy your model, AKS needs load balancer to access that deployed model, right? And by default, it provisions a public load balancer, which has public IP. But you can configure internal load balancer, which has private IP, and it can be accessed only from your VNet. So in this case, I enabled internal load balancer. And after that, AKS is provisioned. And this is the section to deploy model to AKS cluster. And after that, this is a scoring job. So if I run this section, yeah, wall time is 16.2 milliseconds. So yeah, scoring endpoint is working over private IP. So yeah, that's the demo of AKS cluster. So if I go back to if I go back to PowerPoint slide and summarize demo, so basically we provision everything over private endpoint. So for workspace and for associated resources, and we test the VPN access from our PC over private IP. And we also provision private IP of compute cluster and test the compute instance scalable job. And on behalf, we also try on behalf of creation. And lastly, we deploy model to AKS using the internal load balancer, which has private IP. So yeah, that's the demo. So let's moving on to the roadmap. So yeah, it is Azure Machine Learning OLAP roadmap. So it has not explained features, but as you can see, workspace private link GA, and you can also see resources level RBAC in here. So it will do GA in next quarter, and private IP is here. So preview will be started in between October to December, and GA targeted in 2021. So yeah, that's the roadmap we covered today. And we also have references slides, and that's when is Q&A. So Vijeta, can you? Yep.
Hey, Jumbe, thanks. Great presentation. So one question I was wondering was, Private Link Workspace was available in 3 regions for a long time. Is that still the case?
Yeah, thank you very much for your question. So yeah, as of now, it is available in 3 regions, East US and West US 2 and South Central US. But as I said, at GA, so by the end of September, it will be available in all public Azure Machine Learning regions, excluding China region and Azure government. But China and Azure government will be enabled in the next month, yes. So by the end of next month, so which means by the end of October.
Okay, thanks. And what do you recommend is the best way to create a private link workspace?
So yeah, thank you very much for a good question. So basically, I recommend resource manager using resource manager template to provision private link enabled workspace, and because it requires multiple configuration associated resources or etc. So you can automate everything using resource manager template. So yeah, please refer the reference slide. It has the link to the resource manager template. Yep. And we also support the deployment from Azure portal. So for the simpler case, you can use Azure portal to deploy private link enabled workspace.
Okay, great. So we have the integrated notebooks, right? And do they work with the private link workspace?
Yeah, thank you very much. Good question. So yeah, in the past few months, several UI services does not work with private link workspace. Now, all service will work with private link workspace except integrated notebook. So, and it will be enabled by the end of June in the current roadmap. Okay. Hey, Vijeta, and I also have one more question on CI. So I remember, most of VM has auto shutdown feature, right? How about compute instance? Compute instance has auto shutdown feature?
Yeah, Champe, great question. So we have heard that feedback from a lot of customers, and we have taken that feedback, and we're actively looking into ways to address this and provide auto shutdown and auto start capability. So we are looking into that actively right now.
Okay. And do we have any workaround functions?
So right now, because Azure, you can use through SDK. You can do the control operations like stop and start. So you can script it, and using Azure functions, so you can trigger it. But we will kind of make it much easier for you by putting the support in the platform.
Okay, thank you, Vijeta. So yeah, so that's it from our side. So yeah, in this presentation, yeah, we explained how to build a secure and compliant Azure Machine Learning platform. And yeah, I hope you can try it. So yeah, thank you very much. And please enjoy the rest of Microsoft Ignite.